Yeah.
University?
NII, National Institute of Informatics. This is collaboration between Seogang University, Nami Lee, Jinhwa Kim, and Nguyen Trung is one of my PhD students in Korea. Okay.
He's from Vietnam.
Yeah, from Vietnam. So the title is Thematic Analysis by Discovering Diffusion Patterns in Social Media, an Exploratory Study with Telescope. Basically, this is quite similar with the first presentation about the understanding the what kind of topics are concerned in Twitter. Right? How many people are interested in a certain topic, which is called in his paper sentiment. Okay? But in our case, we want to focus on the diffusion, how the informations in Twitter can be diffused on public, on other people. So we want to model this kind of diffusion patterns to understand our society, right? So as the first presenter explained, Obama. Also, we had a presidential election in last December, and yeah, in Korea, and people are tweeting a lot of information about the election. Right? I like this guy. I don't like this guy. Something like that. So I understand. We want to understand how a certain information is diffused, right? So this is kind of it can be one study in social science, also in our perspective, engineering perspective. We have to develop a certain software system to make this process automated, right? Because in Twitter, the data is really huge, and we cannot process the data manually. So we have to develop a certain software to understand, to analyze the large amount of data. Okay, so yeah, and the goal is understand our society from the social media. So what kind of information is flowing in Twitter, in social media, Facebook, Twitter, any social media. So, and also one step further, this is our goal. I mean, not in this paper, but finally we want to fulfill this kind of goal. We want to predict certain events in certain social events before it really happened. It means, okay, for example, if you have a presidential election tomorrow, I want to predict who will be the president today, not tomorrow. Before the election, we can, okay, who is more popular than others, then we can predict this guy will be the president tomorrow, something like that. But this is a really difficult task, but hopefully we can fulfill this kind of task. And also the data is really huge. I think Mr. Choi, he also working on Twitter, and the first presenter also working on Twitter. The data is really big, right? So now people call this problem is big data. Anyway, really big. So it's really difficult to understand. It's really difficult to collect all data from the Twitter. So anyway, this is really difficult. And we want to develop the software And also we want to find a certain target domain. So why we have to understand the events from the society, and how can we use this detection process? So what kind of domain will be applied by this system? The contribution of this work is we have modeled the diffusion patterns from the Twitter and understand what kind of topic, what kind of themes are there in diffusion patterns. And also we have developed a Java-based software. I will show you. And finally, this kind of diffusion pattern has been applied to decision support system for marketing. So if you are running some business or company, you want to promote new products or new service to your customers by using social media like a Twitter. But how can you send a Twitter? Can I say that? So this is a kind of difficult process. How I can encourage my customers to buy my product by sending the tweets to customers. So diffusion pattern. So we have measured, we have designed two main indicators for modeling diffusion patterns. So, okay, here this is a kind of Twitter. I mean, social networks in Twitter. People are following other people. Then there is a social relationship. Okay, you have your own Twitter account, and I have my account, and I'm following you, and there is a social relationship. So if you publish a new tweet, then I got the tweets automatically. So this is kind of social network, which is directed, but this is not symmetric. So I am following you, but you don't need to follow me. So this is a asymmetric network. Okay, if there is new information, people are following and got some information, and also they can retweet the new information. Then this information is propagated along the following relationship, like this. Okay, so finally, all users got the information. But the problem is how the information is propagated. So we propose two indicators. One is coverage, second one is sensitivity. So coverage. So we don't consider we only consider RT. RT means retweet. When people are retweet, we assume that this user is interested in that tweet, that information. So in this case, how many people are retweet for certain information? So the first case, the red information which is marked in red, only 5 users are retweet. So only 5 users are okay. Basically, this one is the user who has published the information. But anyway, the 5 users are retweet. It means only 5 users are interested in this information. And in this case, 1, 2, 3, 4, 5, 6, 7, 8. 8 users are retweet the information. So this information might be more covered to the social network. But also the second indicator is the sensitivity. So once there's a new information, the information is diffused along the social network, like this, like this. Okay, how can I go? Okay. So sensitivity means how quickly people are retweet. It means once you got the information from the people, then everybody don't want to, how can I say, I don't want to retweet all the tweets. I want to select only few tweets for retweeting, right? So sensitivity means how quickly I tweet, people are retweet. So in this case, even this case, in this case, even the coverage seems very low. I mean, lower than this one. The sensitivity is very high. I mean, people are retweeting very quickly. Retweet. If there is a kind of very emergent information like earthquake or flooding or some natural disaster, then people are retweeting very quickly. But in this case, even the coverage is very high, the sensitivity is very low. I mean, lower than this one.
Propagation speed.
Propagation speed, yeah, exactly. Yeah. So we propose two different indicators. Then we try to integrate these two indicators into one, because given a set of diffusion patterns, we want to compare, right? So we want to integrate and combine them. Then by using the weighting factors. I didn't put the equations in this slide, but if you want to see, then you have to go to the paper. Okay, once we have the indicators, integrated indicators, then we have to understand what kind of topics has very high coverage rate, right? So which is called thematic analysis. In this case, we just choose three different topic themes, but actually we have to do it automatically. So we have to extract a new theme automatically, but in this case we just predefined three different themes. So, and target domain. In Korea we have three different major telecommunication company. So we try to understand how they are using Twitters. I mean, the business are using Twitters. So one theme is promotion. Promotion is like, okay, for example, Apple. I have a new product like iPhone 5. Then this information, I mean, they want to send this information to the customer because they want to sell as many iPhone as possible, right? So this is a promotion. And second one is informative. So this is information. They want to explain new information to the customers. Okay, so for example, LTE. What is LTE? LTE is, what is LTE? Yeah, something like that. There is a new communication technology, so you have to use this, blah, 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 blah. Right? So this is informative. And finally, the third theme, topic, is notification. If there is a new rules, if there is a new price, if there is new new information to be notified to the customers, then they tweet, right? So there is three different themes we define. This is not the automatic way. We manually do this, right? Then we have developed a tweet scope. So here, three tweet accounts: LG U Plus and Orle Mobile and SK Telecom. This is the three main telecommunication company in Korea. So we put 3 different accounts in this system. Then this system is monitoring all tweets, how the tweets are propagated, diffused to the customers, and so on. When, how, and so on. So all information. Then we can draw the data in this system. This is a standalone application, so, okay, already finished. So this system, if you want, we can provide this is, I can send you, so, yeah. The conclusion, so I didn't put some graph chart and so on, so you can go to my paper, you can see how the information is propagated and so on. So conclusion, we try to model the diffusion patterns by understanding the lexical patterns, lexical effect. What kind of topics in that tweet? I mean, according to the topic of the tweet, the diffusion pattern can be different. In case of promotion, for example, the Korean companies are put some keyword like event. Okay, if you are retweet this tweet, then you will have some chance to get some reward, something like that. So people are retweet quite many times. So somehow we can understand how the information is diffused depending on the topic, depending on the theme of the tweet. And also we need not the standalone application. I got an email from my student. He said the web-based application is developed today. So we will open the web page, hopefully in this week. So this web-based application is open to any people. So if you are logging in the system, if you put some account, so I want to follow this guy, I want to monitor this guy, this account, then you can understand how the tweets are propagated. So this is I think this is quite interesting application. And big data issue. So actually the guy already had questions about the limitation of API. So the Twitter has some restriction. You can use an open API. I don't know, 1 million. I don't know how the number of the limitation, but there is a limit that I can call the API for 1 hour. So even there is more information we miss. This is natural. So this is a problem, practical problem. But somehow we can buy the data from Twitter. If we pay the money, then they will provide the data, all data. And also there is another way, tweets fire. I'm not sure. And also there is another way to collect the data by payment. So anyway, there's a big data issues and also Twitter API problems. And also I have another advertisement. So we have the another special sessions with David. I don't know how to explain. Camacho in Madrid, and also Professor Pan-gu Kim, Joseon University, Korea, and also myself. This is ICCCI in Craiova, Romania this year, September. This is like a social understanding and mining session, and we organized some special issue also. ICCCI.
The deadline was extended to the end of this month. We still have a chance.
The deadline will be extended again, so don't worry.
The
So-
deadline was the middle of April, I think.
No. Now, officially, they announced the deadline is the end of March,
Yeah.
but I think the deadline will be extended again. So just let me know if you're interested in participating in the session. Thank you very much. I didn't prepare the slide very carefully, but hopefully you understand my idea.
Okay, thank you very much. And it's a time for questions.
An idea related to viral marketing.
Kind of viral marketing and word of mouth. There are so many papers to understand the diffusion patterns, but I'm always confusing why these guys are working this topic and how this information can be applied and where. So viral marketing can be one candidate, and also some recommendation systems. And that's why we choose the telecommunication marketing systems. So I met one guy from the Korean telecommunication company, and they are very eager to use this social media to send an advertisement to the people. But just like a spam mail, people don't consider very carefully, okay, this is spam, I don't want to read. But the company, they want to send very useful information to the people. So they want to understand how the information is properly